Twitter stuff taken care of. Get our bots going. All right. We should be good. So, hello everyone, this is Chris Ingerson, and it is December 14th, and this is the December 14th TextQuest Devstream. So, today we are going to be continuing our work on the wizard cutscene, well, the Canyon wizard cutscene. Specifically, I think today is largely going to be about the wizard actually showing up. I was hoping to get to Karante stuff tonight, but I think we're going to take it a little slow, and we're not actually going to get there. But for those who are curious, I have redone quite a bit of the models to better match what Karante outputs, which basically involved redoing all of the ropes so that they're rotated by 22.5 degrees, so that the flat parts of the rope are facing up and down, then left and right. And that's true for all of the ropes, including the small ropes. So that took a fair amount of, actually that took pretty much all of last night. That's what I was doing all of yesterday. And I have thought through some more about how to structure this scene, and I have come to the conclusion that to get this bridge collapse scene to function properly, I am going to be looking at no less than 4 individual bridge models. And I don't mean like one bridge over to the left and a second bridge over to the right. No, I mean 4 different models of these 2 bridges. So we're going to have an optimized version that I was working on a little bit before the stream. We can look at it a little bit in Maya. And this optimized version, really, it's basically the same. The only difference is that it has the end caps cut off, which seems like a minor optimization, but you also have to remember there are 15 small ropes per bridge, or well, 15 small ropes on each side of each bridge. So that's 30 ropes there, plus the 4 larger ropes containing them. And each rope has 16 faces on, well, 8 on each end. So that would be 16 times 34 for one bridge, which is what? Let's see, off the top of my head, that would be 184 polys per bridge that I would be reducing. And I mean, that's a little over 360. It's like 368, I think. And that's not a ton. 368 polygons is not going to suddenly make this run on toasters. But you know, they are polygons. Which does mean I'm going to have to restart you. Give me a second here. So that would be, you know, almost 400 polygons per, well, not per bridge, in total that I would be saving, and that would definitely help with some amount of optimization, which is why I'm going to have, so that's one of the models. Then we'll have the Karante version of the model, which is actually, you know what, I might be able to get away with, nope, 4. So we have the static version that's optimized, then we have the Karante version of this, which is basically the exact same, but with end caps on all of the ropes. Then we will have a simulated version of Karante for the actual collapse for each bridge, and then we will have a final resting bridge model that has basically whatever Karante's final positioning is, but has been optimized to not have end caps that it doesn't need, etc., etc., etc. So yeah, we're looking at 4. We might be able to get that down to 3, but I'm pretty sure we're going to have 4. Actually, no, we're only going to have 3 in game technically, but I have to model 4. Because the second one, the one that has cut ropes, which I have in a different scene, but it's not here, is necessary for Karante accurate modeling, but then we have to simulate everything in Karante. Then we have to export that to Maya, clean it up, bring it back into Unity, and export that animation, and then, yeah. So that's a whole process. That's a whole pipeline that we're going to be looking at. And it is a lot. But hopefully we'll have some amount of fun time trying to figure that out. In any case, let's go ahead and jump in here and show you what the current scene looks like. I haven't done much with the actual cutscene itself, but I have created some collision geometry. So the planks no longer have box colliders on them. Instead, they don't have any colliders on them at all. And I'm using invisible collision geometry to make the traversal of these bridges a little bit more smooth. I do have one problem with it currently. Initially, getting onto the bridge, so the very first plank is a little steep for the collision geometry, so you actually kind of slow down a little noticeably, and you'll see what I'm talking about. You see, I kind of like awkwardly slowed down as I climbed this steep geometry here. We also have this problem of like there's just a gap here. So I'm not really sure what I want to do about that. I kind of want to have another plank, another piece of wood here that's just angled to handle that. It's just going to be kind of awkward because it's not, I can't really have it be the same size or else it's going to go into the posts, and I can't really have it smaller, otherwise it's not going to be attached to ropes. So I'm kind of stuck in a weird spot here. Don't really know what to do about that. I don't really like having this gap here. I feel like it's weird. It's just a weird design. But the alternative is to have the last platform or the last plank here clip, and that's not exactly something I want to do. In any case, so this is the collision geometry. You'll notice that I'm not bouncing up and down like I was in the past because it's just smooth geometry. So it's a lot better. We can still walk off of the bridge in certain areas, which I'm not really too worried about. I'm not going to try to prevent that. That's just something that I want to be ready for. We can still climb on top of these, run across these if we desire. I don't know why you would desire it, but that's the current state of the models. Basically, all of last night and Tuesday night after the stream was spent remodeling this stuff. Oh boy, I do not like doing the amount of re-UVing that I had to do. It was just kind of frustrating to have to do that all again. But in any case, we're going to be focusing on the wizard's appearance for this cutscene. I probably should have just done it while I was playing. Currently, we have the wizard just popping in, and then the player getting moved to position and then dropped. So what we're going to eventually have happen, and hopefully by the end of tonight, we're going to have. So we're going to get here. So you'll notice I've lost control. We're going to get magicked to a specific position. The wizard will show up, and then we are going to. Oop, I can move again. Good. The collision is still here. That's kind of weird. I didn't think about the collision still being here. In any case, so we're going to have the wizard appear, and I think I know how I'm going to do it. It is going to be quite fun. So originally I was going to have him drill in from the ground, but I think it's going to be better to have him fall from the sky, because the drilling can be used in other parts of the game, especially the latter half, and it's going to be a lot harder to do falling from the sky in the latter half of the game. So what I'm going to have happen is while you're in the magic grasp of the wizard, he'll still be invisible, you won't see him yet, but instead all of his letters will come crashing down from the sky, creating like large dust clouds and whatnot, and then they'll just form into the wizard, and then his beard will pop out. So again, trying to be a little bit over the top with how the wizard shows up. And once he does that, once he actually shows up, then he'll, push you back all the way over to here. It's so weird not having a mesh, but having collision. So he'll push you all the way back over to here, and then you'll see him cut the ropes of the bridge. Then you'll see the scissors that he generates, which will be, of course, giant magic scissors. He will then move the scissors over to this side, cut the bridge over here, causing it to fall onto the other side, and then we'll be let go. He'll release the magic, he'll laugh, he'll shoot off into the sky. So that's the approach that I'm going to take. I think if we're really good, we'll probably be able to get to the Karate stuff tonight, but I have my doubts, admittedly. Just considering every time I say we're going to definitely get to this thing tonight, we never end up getting to the thing. So, All right. So first things first, let's go ahead and open up timeline. We're going to look at wizard appears. All right. And we have the player control getting set away. That's good. Okay. So next we're going to have. Wait a second. Does he show up as soon as you get grabbed? No, it doesn't matter. That's not what he's going to do anymore. Um, so, how to structure this? Because he's kind of going to show up uh, in a. Well, I mean, he's not going to be there originally, so he has to be invisible until we need him. Okay, so let's go ahead and move some of this. Out of curiosity, I'm going to go ahead and enable this. Can I fudge the sorting on this, on these beard things? Surely I can, right? Order of -1. Oh, no, that's, yeah, that's right. And where is your order? Oh, you're all ordered at -1 as well. Okay. Then we'll order you at 0 so that you are always on top. Okay. So the problem we were having, and you might not have been able to see it very well on stream, is the wizard's beard was rendering behind his body if you got far enough away, because the way Z depth sorting kind of works with sprites is it's basically a like size on your screen kind of situation. So now you can see that the beard is always going to be in front of his body, although admittedly the mip mapping that occurs as it gets farther away, well, it's not really mip mapping, but oh crap, I forgot about that. Yeah, triggered the cutscene. Can I move? And there we go. Okay. So let's go ahead and stop playing. Okay. So this is going to be interesting. We are going to want to have his. Well, no. Hold on. Is it better to have them separate from him? Probably. So we're going to actually keep this wizard as is, and then we're going to more or less make a duplicate. And actually, you know what? Let's go ahead. I'm going to go to cutscenes, bridge collapse. Do I want to have it just below that? We'll just do it. Move these guys underneath wizard appears. So we'll call this one the wizard soul fragments. I think I called them soul shards actually in the past. Soul shards are, I guess, just the term I'm going to use for the individual letters of a character. Okay, so we're going to want to move pretty much all of this. Let's go ahead and break this prefab instance, which I seem to have forgotten how to do. I thought that I could right-click and do it, but apparently not. That's super weird. Really? That doesn't seem right to me. Game object. There, break prefab. I thought that was a context thing, but I guess not. Okay, so the reason I did that is because I didn't want any changes to the actual wizard to affect the soul shard stuff. So let's get rid of the laughter and casting. We'll keep the model. Well, no, we won't. We don't need you. We will keep the body and everything else. So basically what's going to end up happening is we're going to have the actual wizard model turned off. Then we'll have his soul come in, and as it assembles itself, then once it's fully assembled, we'll swap it out for the actual wizard. And the reason for that is so that I have a slight performance gain there because I don't have things like animators and particle effects possibly going. And two, it just means that I have a point of reference so I can easily look at this to make sure that everything's lining up properly. All right, so let's go ahead and this is going to be so weird. Do I want this to be his final positioning? Yeah, that's not too bad, actually. Well, I wonder if it would be better. No, it should trigger as soon as you get to the other side. Hmm. All right, so we're gonna want. Ah, crud. All right. Actually, you know what? Before we do this, I'm going to do a little test to see what happens. I am going to intentionally try to trigger this cutscene from a position where I will have to pass through a collider to get to my eventual positioning. So let's go ahead and play this. So basically what I'm going to do is I'm going to run across the ropes and then jump off to the left so that when the cutscene triggers, I'll be forced to lerp through the post. If I'm really good, I'll be able to do the post. If I'm not so great, then I'm probably going to have to settle for like the rope. But either way, it's going to do. Okay, yeah, the bridge collapsed. That's not quite a good enough thing. Let's try that again. Actually, no, the easiest thing for me to do would just be to do no clipping. Alright, so I'm going to go ahead and no clip here, and then when I activate, I should... Okay, yeah, see, I clipped right through it. So that's, I mean, that would actually be the preferable behavior, just moving through something. Much better than getting stuck on the other side of it. But that does mean that I probably shouldn't have the collision, or have the trigger for this cutscene be right here. Instead, it should probably be slightly in front. So you would get to here. The main thing is I just need to make sure that I do it before you get to like here, before you can see that this doesn't really go anywhere. So we're going to go ahead and say probably around here, and it'll span the entirety of the of this width for this section. Let's see how far I can actually go. Oh wow, I can't go very far at all. So that's the corner. Let's see what the absolute minimum would be. How far back can you see that edge? It's not ideal. So pretty much, yeah, pretty much right here. I really don't have much room to work with. So it is almost as soon as you get off. It's just not going to be right at the bridge posts. So let's go over here, bridge trigger. All right, so we're going to move this up to, I think, here. I think that's fine. Go ahead and move you up. We'll do 32.5. And we'll have you span the entire width. So 30? Nope, 25. Almost. 24. Excuse me. We'll do 0.5 increments. Done. Turn on snapping. And... oh, wow, really? 23 then. Nope. 22. Oop, not 232. Oh, come on, really? 22.5. Lame. Alright. 0.25. Go ahead and go over 1. There we go. Actually, no, we'll just round that up to even 23 so that I got a little bit of extra spacing on the edge. Okay. That way you can't somehow jump over it and redirect yourself onto the platform. I don't think that's possible, but you never know. Some players are really good at this. Let's go ahead and turn you back on to 1. Turn you off again. And get rid of you. Alright, so now the cutscene won't happen until you're a little bit past the bridge. And we're also going to want to do... let's see. Wizard appears. Alright. So, where's our magic point? Here we are. So, for the magic point, we're probably going to have it somewhere like here-ish. Let's go back down 1. That seems fair. Yeah. So it's a little bit into the trigger, but it's not really much farther past it. Yeah, I think that'll work. Let's go ahead now, turn on our soul shards, and now we're gonna going to get to animate this. So first things first, actually, let's go ahead and move our wizard back. Probably about there, I think. I'd say that's fair. I guess before we do anything else, I'm going to test that just to make sure that it looks right. We are going to have tons of particle effects, by the way, tonight. Because we're going to need a lot of dirt and dust. And I guess that would be pretty much it. Okay, so we're going to go back to our positioning. I like that. That's decent positioning. Not too close, not too far away. All right, let's go ahead and stop. All right, so this is where our wizard is eventually going to end up. Okay, so we're going to go ahead and move basically all of this, although we are not going to move the beard under the eye. We will put it there eventually, but for now it's actually going to be separated. Okay. There's not going to be any blend probes going on there. That was completely pointless for these guys. Do I have anything else that I need? No, casting shadows, no, nothing else. Okay, good. Alright. So I'm going to move all of these letters really far up. And just to make sure that it's... Actually, you know what? Before we even do that, I'm actually going to space them out before I move them. Alright, so... let's put the D over here. Do I want to position? Yeah, I probably should. I might as well just position them in their individual spots right now where they're going to land, and then we'll sort of reverse engineer this as we go up. So let's go ahead, throw the R back here a little bit. Oops, not down like that. Let's go ahead and turn on some snapping. 0.25 seems like it would be fine. Okay, hold on, just double checking these. Position Y. Alright. Oh, right. Text container stuff is obsolete. Isn't that wonderful? Same on you. Cool. Clear this stuff. There's our R. Let's go to our A. Right about there. Put you here. Then our Z. One more down. Get our I. This. And then our W, which I guess will go ahead and be, really, there. Alright, so that's what our wizard body looks like. Go ahead and collapse some of this as much as we can. I feel like I should probably move these into the wizard appears cutscene. Actually, no, this should go under the collapse cutscene. Alright, so that's where it's going to be scattered to. That's what he'll look like. The beard is going to come down independent of these guys, although if I had to pick a spot, it will eventually land... let's see. Here-ish, if I had to guess. That one's going to be a little bit into the ground, which is fine. Okay. So, real quick, I'm going to go ahead and take a look at this in game. I'm also going to go ahead and move my test spawn point a little bit closer so I don't have to keep running across the entirety of the bridge here. Let's put you here. That's probably fine. Move you up a little bit. Move you back here. Rotate you. Or I guess not rotate you. All right. I just want to see what they look like. Make sure that they seem like they're in a good spot. Because I want them to come down close to you, but not too close. Just because if they're too far away, you won't be able to see them very easily or very well. So this is a good location, I think. All right, let's go ahead. Stop playing. Cool. So now we're gonna have to make this cutscene in reverse, which is going to be fun. So let's go ahead and yeah, this is gonna be. That's fine. Okay. So we're going to go ahead and put the body, or put an animator on the body. Miscellaneous animator. It's not going to do anything, but it's going to hook into the timeline. So let's go over here to Wizard Appears. Let's add an animation track. I'm going to go ahead and drag the body in here. Okay. Actually, you know what? No. Let's delete this. We're going to get rid of the body animator. So we're going to have animators on the individual body parts. Just because that gives me a little bit more control over them. So let's go ahead and say, go back here, Canyon Wizard Appears. Let's go to another track subgroup. We're going to have the body. Add an animation track. We're going to actually have, let's see, we're going to have 7 animation tracks. Okay. Then we're going to go ahead and drag these in. That was weird. What is this invalid operation thing? Okay, whatever. Clear that. I have the I, Z, A, R, D, and then finally the beard. All right. Now we get to animate all of this. So, for that's interesting. No. Let's go ahead and mute you. I don't really care about you yet. Although you could be useful when I'm trying to position things. We'll call this body fall. Then we'll have another one. Well, no, I guess we'll just call it body. Because we have 2 distinct phases. We have the falling, where the individual letters fall down. Then we have the assembly, where the letters form themselves into the body of the wizard. Then after that, we have his beard, which is going to be a little bit of a gag, where his beard doesn't come down, so he looks around, tries to find it, and then beard just lands really hard next to him. All right. Or it could land on top of him, which would be pretty fun. Oh, that would be so cool, actually. Ah, that's even better. Yes. Okay, so this is actually going to move right about there. That's going to be cool. So what's going to happen is the individual letters for the wizard will come down. They'll slam into the ground one by one. He'll form himself, won't have his beard. He'll look around, look up, and then the beard will just smash into him, separate his letters again, but then they'll all just immediately come back, and then his beard will be where it's supposed to be. That'll be cool. Okay, so let's go back here to Canyon Wizard Appears. All right, so now we do have the fun part of animating these guys. So first things first, let's have the first W be where it is. Crap. We gotta turn you off, otherwise you're gonna get annoying. Nope, not 10, 0. Okay. And then we're going to go ahead and go up to 0, and we're going to say the W should be something like, I feel like 20 is not enough. I'm guessing we're going to need like 30. Oh no, we're going to need like 50. I think that's far enough away that you won't really be able to see them very well. So they're going to, just out of curiosity, to see what this looks like. The curve, I'm guessing, is easing in right now. We're probably going to turn that into a ease in, but not an ease out. So that's pretty much it for this one. Okay. Let's go ahead and say, get our next one, which is going to be an I. Let's see. I want this one to be landed. Let's see. We'll separate these by half-second intervals for now, but I think we're gonna end up spacing them out a little bit, not asynchronously, asymmetrically. But in any case, for now, this is gonna be like 1, 0. Should I worry about position X? Maybe. I mean, I kinda think I should. Yeah, it should be fine. Yeah, paranoia. Alright, so this is going to go over to 30. We're going to be up at 50. So that's it for that. Let's go ahead and go back to this real quick, just because I want to make sure that my W is set to be at position 0 for X. And I guess probably position Z. Except I don't know if you'll... Oh, crap. What the heck? Really? Really? You're gonna do that? Great. Now I gotta... Okay, well, nuts to you then. Guess what? We're gonna be editing this. Those values are gonna be 0. We can brute force that stuff. There we go. That's not super great, though, that I'm going to have to brute force that. Alright, let's go ahead. Stop that. Let's go back here. We have anchored position Y and X. We're going to need anchored position Z for this. So let's go ahead and go over here to 30. 1, 0. Oh, interesting. Why did you work at 0? Well, whatever. Let's go ahead and stop you. Wait, hold on. What? What's going on? You're marked as if you're recording, but you're not. Oh crap! That's why. Because I was looking at the wrong thing. Of course I was. There we go. All right. Let's go ahead and stop playing. Take a look at this. Add a key. 0. Add a key. 0. Making sure that it's 0. Okay. Let's go ahead and collapse that. Save out. Start recording for our Z. Let's see. Oop, I almost did that in reverse. 120. Let's go ahead. 0. 5. 1. 0. 4. 3.5 is what it is. Let's go ahead and stop it. This is kind of annoying that I have to do this. 3.5. Right? Nope, negative 3.5. I'm sorry. Yarg. Negative 3.5. Alright. So that's good. But we still need to do some stuff. Let's go ahead and say 60. Our Z is going to be at 50. So they're all going to start at position 50. And then they'll basically, as you can see, they'll come slamming down one by one. The idea there is that it's just a unnecessarily dramatic, over-the-top entrance, because I'm all about those. and it's just something nice to look at. And hopefully it shouldn't take too long. I'm hoping I can get this entire wizard falling formation, well, falling, forming, and then pushing you away so we can cut the bridge to be 15 to 30 seconds. I would be seriously surprised if it turns out to be 30. I'm kind of aiming for more like a 20-second thing, but we'll find out. All right, let's go to A. Okay, so for A, looks like we have 0 here, so I'm going to go ahead and make this 0x. Crap! I don't want to do it that way. Let's go ahead. 50, negative 2.25, because I know this is going to work up. Go ahead and set you at 0 again. Go back here to 90. Set you at 50. All right, let's take a look at you. Set our value to be negative 2.25. Is that right? Yep, that is correct. All right, let's see. What about you? I don't really need this, but I guess I might as well edit it and set its time to be, I don't know if 1, okay, so that's frame count, that's good. So this is 90. Might as well make it 150. Shoop. All right. Okay, so that is the A. Let's go for the R now. This, I want to go to 180. This is our R. Oh, come on, really? The scale is, of course it is. So negative 3, position Y of 0, and negative 4 in the Z, but that's going to break, so, oh look, it kept it. That's nice. And surprising. I wonder what changed. Alright, let's go up to 50 for the Y here. That should pretty much be it, so let's go ahead and, real quick, I'm curious to see it. Cool. Looking good, looking good. Let's get our D recording. So this is going to be 210. Let's go ahead, come over here. We're going to have negative 4. Negative 4 as the positioning. Negative 0. Come on, really. 0 as the Y. 0, of course. Okay, we're going to go back to 150. Do 50 Y. And we'll be done. Alright, so let's go ahead and change you. Add a key. 0. Alright. So, oh, and before I forget, let's go ahead and stop playing. I want to single out our scales. Not entirely sure why they were off by that amount, like that very small amount, but I do want to make sure that they are all 1. Okay. Make sure my beard is like that too. Good. All right. So now, if we want, we can go ahead and preview that. So that should show us all of the letters coming down. Cool. Next, we're going to need the beard should probably be animated too. The beard doesn't come down all at once, along with the other ones. Like I said, it's going to come down afterwards. So we'll leave the beard alone for now, but I will add some track subgroups here. So there's going to be, I can't really subdivide this. This kind of sucks. Actually, you know what? No, this is fine. Go ahead and drag this up here. Drag this above it. Okay. So we're going to call this particles. I'm going to minimize this for now. Then we're going to need some play particle system tracks. So Here's the question: should I have multiple particle systems, or do I want to try to have one particle system? I'm probably gonna have two or multiple ones, just because it W particles. Mostly because it probably would be incredibly hard to try and time a single particle system to have a bunch of particle effects happening. So, all right. Go ahead now to play particle system. And before we do anything, we're gonna stop previewing. We're gonna go ahead and make some particle effects. So let's go ahead and say effects particle system. Let's go ahead, come down here to our renderer. We're gonna look for dust. Yep. Look for dust. Do I also have dirt? I have both. I feel like dirt will be better because it is on a dirt surface, so dirt is probably going to be the one that's mostly there. We'll have dirt and dust, but dirt is going to be the main one. Let's go ahead, move you down, over here. Oh my. Zoom in. Okay. Right about there. Perfect. So we're going to want... I wonder if we have... actually, you know what? Real quick. Oh, that's interesting. They added a restart button here. Used to just be simulate and stop. All right, real quick. I'm going to look up... No, hold on. I'm going to look up some videos of comet collision, I suppose. I mostly want to see the plumes, like how they spread. Suppose we could try to do this. Oh no, I need to see it in motion. So let's look at the Jupiter collisions, because I actually remember this one. Not this, though. And this is probably not going to give me what I want. Doing research live. Sucks. Alright, well, we'll just approximate it. That's fine. Alright, so let's go ahead and select this. Let's play this out. So we're going to have, I think, a big plume of dirt initially, and then we'll have dust kind of settling in there. Although maybe I should have just the dirt plume as our particle system, and then we'll have another particle system independent of the dirt ones that will slowly create more and more dust as the wizard pieces arrive. That makes sense. All right, so we're going to change this a little bit. Our emission is not going to be... Well, our shape is actually pretty good, but our... Let's see here. Emitter velocity... We're not going to do play on awake. Let's go ahead and stop this for now. Play. Convert this to a gradient. Although, actually, no. We'll convert this to random between two colors, I think. Random between two gradients. That's pretty good. But we're going to do color over lifetime. I know that. And this is going to be... We have a couple of things we're going to do here. 90, set our alpha to 0 so it fades out. Set our alpha to 0 so it fades in. 10. Okay, so you can see that it's a little bit better because it's not just going to suddenly pop into existence. All right, let's go ahead and come up here. We're going to have a random between two colors here. So we're going to want probably like a orangish, I think. And then the other one would probably be like a more brown. Although I need to make sure that it's distinct enough to... No, that's not bad. Yeah, that's fine. So there's our dirt coloring, but we now need to work on emission. So we're not gonna have any emission over time. Instead, we're going to have bursts. We're going to have. Let's go ahead and stop this. We're gonna have a count of. Can I do like 100? That's gonna be a lot. That also looks really dumb. So let's change that to a count of 30. And that's actually kind of a bit much. Yeah, but it's going to be a lot of it, so we'll go up to 50. And then we're also going to go ahead and, let's see, max particles. We don't actually care about you. Start size. No. I don't think we have to worry about size. We're not going to do any sort of scaling from 0 to 1 or anything like that. How else do we want to do? We do need to have gravity affect this. So, let's see. I think I can do speed over lifetime. Or I guess I would do force over lifetime, wouldn't I? Let's go ahead and play this. And I guess we'll add like -1. Mostly because I'm curious to see if it actually... Okay, let's try like -10. Also, we apparently do not want Y. We obviously want Z. Duh. Ooh. Okay. Well, oh, crap. Actually, let me grab the gizmo. That's not bad, actually. So I like the effect. We just need to change that up. So should I have this? No. Well, five's pretty good actually. That gives me some nice spread. Might bump our emission up a little bit. Can we do 100 then? See what that looks like. Although, yeah, here's where it gets a little weird. What if we make this 30 and cycles? Can we do like 3? I don't know what that means. Does that mean I'm just getting 3 bursts per thing as opposed to 1? It does. Okay, so that's not actually what I want. Where's the interval, what I would expect? Because this is definitely not 0.1 seconds between each interval. But I can also slow down or change our lifetime. Let's change our lifetime to 3. Let's see, so 1, 2, 3. Okay, that's definitely not what I would expect it to do. I'm going to see when it actually disappears. Okay, so let's shorten that to 2. Okay, so is it vanishing pretty much as soon as it gets to the bottom here? That's actually pretty good. It's like, starts to fade out. It fades out a little bit after it gets to the bottom. But that's, yeah, pretty much instantaneous. Once it's past the surface here, it's gone. All right. Can we shorten this even more? Or is that just going to, like, wait? Because basically what I would like to have happen here is have them happen in rapid succession. But, I guess I would have to do this, wouldn't I? So let's shorten you to like 0.5. Go ahead and stop. Restart. Yeah. Because I probably want, I don't know, like 5 rapid bursts. So we'll shorten this to like 0.1. 0.2, 0.3. Let's see what that looks like. I know that's only 4, but yeah, that's kind of more in line with what I would expect. Okay, let's go ahead and stop this. It's not going to be looping. Its duration is 5-ish. Actually, no, that doesn't work. Yeah. Okay. Let's go ahead and play this. Yeah. So I think I can lower this to a duration of 3 seconds. Stop that. Hit play. I'm actually kind of curious. At what point do they actually go below? I could probably get away with a lifetime of 2.5 actually. Let's go ahead and say 2.5. We'll change our lifetime. Oh, it's already 2. Okay, never mind. Can't get really much shorter than that. Go ahead and play. Okay, that's fair. All right, so this is going to be our. We'll call this wizard body impact. All right. I'm going to just really quickly put this in a variety of. I was gonna say, are we doing random seeds? That's good. I'm just gonna go ahead and quickly duplicate this. Hold on, let me make sure it goes under the right thing. We're gonna group this under particle effects. All right, let's go ahead and stop this. We will duplicate. Let's go ahead and move you over. All right. We'll also go ahead and rename these while I'm in here. So there's going to be impact W. There's going to be impact. Oops, come on. Impact I. On. Push you over to here. Why does it keep zooming me out? All right. We'll call this impact Z. Duplicate that. Impact A. Impact R. So we're basically going to see what these look like when played next to their respective letters crashing down. Impact R. And finally, impact D. All right. Let's go ahead and save that real quick. Let's go back to our wizard appears cutscene. I'm going to go ahead and also move the beard while I'm at it. Come on. All right. So eventually we are going to want it to be where it is now. I suppose we'll have that be an arbitrary like 480. Well, actually, let's see. 300 is 10 seconds. So yeah, 480 is probably, well, no. Let's shoot for 480 is probably fine. 420 or 380. Yeah, we'll do 420. Okay. So that's going to be where it is now. Let's go ahead and position this. Oops, wrong thing. All right. So there's going to be 2. It's actually going to be positioned at 1. All right. And then for the rest of this, well, actually not. So 360 is actually where I want to go. You're going to be up at 50. Out of sight, out of mind. All right. Let's go ahead and stop playing. All right. So here's our W particles. Let's go ahead and drag you in. Wrong thing. I was going to say, why aren't you dragging? It's like, oh yeah. We don't need to control child systems. We don't actually care about that. Let's go ahead and let's make a track subgroup here. We're going to call these impacts. Let's drag this into there. Okay. Let's add some more. Actually, you know what? Can I go ahead and duplicate this? Ah! It is going to duplicate all of that, but that's fine. Duplicate. Duplicate. Can I do all 3 in duplicate? Oh, good, I can. Nice. So we have W, I, Z, A, oh, A, R, and D. Let's go ahead and get rid of this guy. All right. So there's the I, Z, A, R, and our wonderful friend, a D. All right. So with this, we'll go ahead and space these out in the way that makes sense for them. Let's put you right about 60. Come on, there we go. And 90. 20. 50. 80. And finally, 210. All right. So let's go ahead, save this, collapse some of this stuff, and let's take a look at it. Let's go ahead and save, turn off the preview, and go ahead and collapse some of this, see what it looks like. So we should get the individual shards crashing down. Dust should come out whenever they hit. We don't have the dust particles yet. We do have the dirt particles, though. Okay, so we're going to get here. Oh, crud. What? I muted you. What is going on here? I am... What? I am deeply confused. Is this the old one? Is that why? Did I accidentally grab the wrong one? Yes? Question mark? Triggers. Which trigger? Yes. Okay, that's why. Whew. I was going to say, what's going on? You shouldn't be appearing. Alright. So that was a minor oversight on my part. That is perfectly... Wait, no. That doesn't make sense. Well, whatever. This should work just as well. That almost works. We probably don't want them to start doing that until I get into position. Oh, that's super annoying that I can't grab these. So that's 3 seconds on its own. Can we shorten that to 2.5? Now I get to play the wonderful fun game of doing this. There we are. Well, I guess silver lining. While we're here, I can go ahead and smooth out how we want this to happen. So the reason that I'm doing it like this, we're not doing easing in or easing out, is because the way motion works is if you're moving as an animated object or as a living object, you have what's called anticipation. So normally when you move, you don't go from 0 to sprinting right away. You have to have kind of like a build up where you see your body ready itself and then you start running. And all of that's how motion works in natural situations. But when you have things like impacts or collision, obviously that's not the case. You don't start slowing down before you hit something. Well, you do if you know you're going to hit something. But if you don't know you're going to hit something, you don't slow down. So what happens is you're running as fast as you can, and then suddenly something just comes out and you just smack right into it. Which means that you don't slow down. Instead, you just run full force and then you just stop. Or you barrel through it, depending on which one of the thing, which is stronger, you or the thing. And in this case, the thing is the ground is going to be stronger than the wizard's momentum. So we want to have him pretty much. He can start slow, but that's not really going to matter. As long as when he crashes, it's just a hard stop. Okay, so let's go ahead, minimize this, turn you guys back on. Interesting. Let's grab all of this. this out. There. All right, we're going to grab our anchored position Y. Same thing. Grab all of this. Slide everyone to the left. Grab you and you. Oop, wrong one. You. And do that. Let's go ahead and get rid of you. Open you up. Nope. Okay. All right. Get rid of you. Actually, no. Let's go ahead and collapse these. I like to keep things organized. Uh-oh. Did I? No, you should be fine. Question mark. Yeah, okay, you're fine. Crap! I accidentally dragged it. I hate it when I do that. Grab you. Alright. Let's go ahead and grab these guys, move them over. Over here. Position. Let's go ahead, turn you off. Let's open this up. Oh, right, the beard. Oh, crap. Yeah, we ought to move him way farther out now, actually. Okay. Let's drag all of this. Oh, crap. Yeah, there we go. Oh, nope. Come on. I'm gonna put it there for now. Position, Y. Grab you, same thing. Okay, so with all of that out of the way now, and collapse you. Yep, can't do that. We gotta now drag all of our. Can I grab all of you guys at the same time? I can. Isn't that nice? I really do like the timeline stuff. It's quite fun. Okay, let's put you there. Okay. Now let's try this cutscene again. We should actually see the collision events not happen, I guess, as we're moving towards our target, which will be nice. So we move to our target, and oh, and my trap duration did not last that long. Okay, but yeah, so if we rewatch that, you'll notice that the impacts feel a lot heavier now because they don't slow down before they hit the ground. They just wham into it. I probably should have them come down at angles so that they're not like floating above the ground. They should feel like they're submerged in it. So yeah, see, they just hit with a lot more force now. Okay, so next we're gonna go ahead and apply the rotation, like I was saying. So let's come over to here. W, well, I kind of wonder. Let's come over here to 10. If I edit our anchored position Y, can I make this like negative 0.25? I don't know if I want to do it like that. That's too far. Let's edit that. Can I do like negative 0.1? I mean, really, I just want to have the letters partially into the ground so that it feels like they penetrated the ground a little bit when they hit. Let's go ahead, minimize you, open you up. Let's grab you, edit. We'll do negative 0.1. That's decent. Although, I kind of wonder if I should also have them facing the player. No, it's fine. Okay. Although I do want to go ahead and hit record here. Shards body. We're gonna tilt the eye rotation a little bit along the Z. Oh, interesting. Oh, there it is. That's why. That's huh. Okay. So let's do a rotation of 30. It's probably fine. And yeah, we can probably leave it at 0.01. Might as well go ahead and have it at 180, having 0 rotation. W is not going to rotate since it's the main letter in the wizard. I think it makes sense for it to be just straight on, not rotated at all. But pretty much everything else is going to be up for grabs here as far as rotation goes. Let's go ahead, hit record. We're going to have our anchored position Y at the -0.1, and we'll have a rotation of -15. No, positive 15, I guess. Do that. Okay, that means that we're actually going to go back up here to the eye. I really wish I had some sort of snapping. And we're going to change our Z rotation. Oh dear. That's not ideal. We're going to go ahead and record this. Go back up here. Yeah, that's what I thought happened. We're going to change you to -30. There we go. A little bit better. I just don't want to have my I and Z in the same rotation for the most part. Let's go ahead, stop you. Let's go down to our A. 300. Okay. Let's go over here. We're going to record. So our A is now going to be at -0.1. This rotation, I'm going to be a little bit more extreme and say 70. Oops, I'm sorry, -70. A little too much. -60. Nope, still too much. 50 is still a little too much. I might be able to get away with this if we do 0.5 here. Yeah, it's a little bit better. All right, so that's that one. Let's go ahead and stop you. Come down here to R, hit record. 30. This is our R. We're going to say -0.1. For this, well, it's very convenient. We wouldn't want the R to rotate that way. Let's see. -10. No. This one I think we can go a little bit. Yeah, that's good. Again, we're going to go 0.05. Actually, you know what? We might make you 0. It works out. That's fine with me. While we're here, let's go ahead and say... you know what? Let's go ahead and just stop. Rotation... Oh, okay, never mind. Let me go back to here. 270. We need to have a rotation of 0 here. Likewise, we need to do A and Z. I forgot to counter rotate them. So let's go ahead, go to A. 240. We're going to have a rotation of 0. At Z, we're going to have... crap. Let's see. Z will need its counter rotation. Did I do this for I already? Yes, I did. Okay. So that leaves D. All right. So we're going to go to 360. Let's come down here. Oh, crud. Of course, R is screwed up. Because I can't have nice things. Let's see. We want this to be rotated at, I don't know, negative 10-ish, probably. Yeah. Position of negative 0.1. No, 5. Let's go for a negative 20 rotation as well. And you're actually going to bounce back down. That's fine. All right, let's counter rotate at 30 or 300. 0 here. Let's stop. That is so frustrating. Why are you worked up, R? Really? That is not the number that I wanted. What did I say? Negative 20? Dang it. I borked up. I did. Okay, fortunately it didn't actually do anything. Let's try that again. R is going to be at... Yeah, I didn't need to go that far. Is it something like 50? Yeah. That... Wait, actually, is that what my Z is? Ugh, freaking timeline. Let's see. Z... rotation... Z... Nope, then we're fine. Alright, so let's go ahead and just kind of scrub through here. Alright, so that's working pretty well. Go ahead and save that. Then we're going to need, I think, a jostling motion. So we don't want them to just land and then smoothly lerp together. Instead, we probably want them to land, then sit there for about 2 seconds, I think. Then we'll have them jostle and form together, one at a time on top of each other. And then we will finally have the beard come in and smash them and do everything. Alright, so just out of curiosity, I want to see what this looks like. Let's go ahead and play this real quick. I believe in you, Unity. Okay, so we vanish, then... Nice. Although I think my A is a little too rotated. Yeah, it's not the end of it's not terrible, but I want to fix it. It feels like it's too it's rotated to the point where you can't tell that it's an A necessarily. You might misinterpret it as an N. So I just want to make sure that it's at the correct rotation for itself. Let's see, rotation Z. Let's edit key, and it's gonna be okay. Let's come over here to the A. Yep, a little too far again, huh? 50. Yep. No, that's fine. I was a little worried for a second there. There we go. Okay, good. All right. Now here's where things get a little bit more iffy. I don't really want to animate the jostling animation, so I don't want to like manually keyframe the vibration of the letters before they form. So instead, I think we're going to have a script for that can be activated or deactivated. How would we want to handle that? All right, let's go ahead and do that real quick. So we're going to go ahead and say create folder world. We'll have a canyon folder. And we'll call this letter vibration, or letter vibrate. Yeah, we'll say letter vibration. Alright, so this, crap, I forgot. I updated Unity, and of course I forgot to redo all my script stuff. Great, now I gotta redo this real quick. Alright, so namespace sleepyowl.textQuest. So all this script is really going to do is basically have a random, or sort of like a randomization of the object's position. Let's see, Windows, okay. And then a speed at which it vibrates. So it'll randomly assign a position, then it will try to lerp over to that position, and then it will randomly assign another position once it reaches that position, and then it will, continue that until I tell it to stop. All right, so the next thing we want to do here is say public float speed is equal to, we'll say 1f for now. Public float max distance is equal to, we'll say 1f again. And that's pretty much it for this. So we're going to say private transform, cache transform. Oops. And private transform, cache transform, get return, cache transform, cache transform, cache transform is equal to transform. All right. So now that we have that, let's go ahead and have a private bool is active is equal to false. We'll come up to here. I'll say public bool is active. Get return is active. Oops, lowercase I. And set is active is equal to value. All right. Let's see. So we're going to come down here and we're going to say private void update. And for this, we're going to go ahead and say if is active. Then we're going to do stuff. And we're also going to have public bool ignore z axis is equal to true by default. Go ahead and do tooltips here so I don't forget what these actually do. Don't randomly move in the z-axis. We'll go ahead and tooltip these as well. Maximum distance, a random point can be, oh, you know what? From I can't spell. The origin. And then tooltip. How fast the object vibrates. All right. I think that will work, and we're also going to want to do this. Private bool, not bool. Vector3 local origin is equal to vector3.0. Should be good. And next we're going to go ahead and say, let's go ahead and do this. So we're going to convert this into kind of a function. We're going to say if not, if is active does not equal value. And then we're going to go ahead and say if is active origin, or local origin is equal to cache transform dot local position. All right. So with that, we're going to go ahead and say, let's see. So we're going to need a target position. So that's going to be private vector3 target position is equal to vector3 dot 0. Let's see here. Should I? No, that's probably. Oh, right. That was the third field. I knew I needed a third field. So we're going to say public float stop threshold is equal to 0.1f. Tip. How close the object must be to its target point before choosing a new target point. Okay. So next we're going to go ahead and say, so if we're active, we need to move to a point, and we're going to say if, well, we'll go ahead and make a function real quick to generate a new point. So private void generate target. We'll say target position is equal to new vector3 mathf dot sorry, random dot range, I think is what I'm going to want from origin, so local origin dot x minus max distance, comma, local origin dot x plus max distance. Okay, so that's one of those values, and I'm basically going to want to do that for all of them. So that, and then this one's actually going to be a little bit different. We're going to say ignore z-axis question mark. If so, then we're going to do something very specific. Otherwise, we are going to do the random range. We're just going to say origin dot z. Okay. So let's go ahead, come over here. This is going to be y. Okay. And next, we're going to need to say, let's go ahead and private bool. We'll make it a function. I normally would make this a getter setter, but we'll make it a function for now. So we're going to say private bool is at target. And we're going to say if cache transform dot local position dot x minus target position dot x is greater than what was my threshold? Stop threshold. Return false. And I guess we'll have to do a math f dot absolute, which is a little expensive, and I don't particularly like doing that, but oh, wait, sorry, did that wrong. There we go. We're going to go ahead and say return true at the end here. Let's go ahead and paste this in a couple of times. So, actually, you know what? So this is going to be y, z. We're also going to go ahead and say if not ignore the axis, and yeah. because we don't actually care about, we shouldn't care about the z-axis if we aren't paying attention to it, so we shouldn't try to factor that into if we're at the target or not. Oops, right, forgot a semicolon at the end here, which I guess tends to happen when I have super long ones like this, so I might as well. There we go. It's a little messed up, but makes it easier to read, certainly. Okay, so I'm going to say if is at target, else we're going to be moving over towards it. So we're going to say cache transform dot. Do I have a translate? But that's not actually what I want. I thought that there was like a move to function in transform, but I guess not. Transform vector from locals. Oh, okay, that's fine. Sibling index, parent, rotate around. That might be what I was thinking of. Child of, get sibling index, components. Huh, really? Well, alright then. Trying to think about how best to try and handle this. I really don't want to lerp between the positions. That doesn't really make sense, and that makes it look very static. Instead, it should be a lot more dynamic, really. Does that mean that I'm going to have to find the direction between the two vectors? Woof. Alright. Well, I guess if that's the case, then we can go ahead and say private vector3 target direction is equal to vector3 0. Alright. And let's see here. So we're going to want to say so when we generate a target, we're going to have to do this. So we're going to need to say, to get a direction, I think we subtract the two vectors, I believe. Hold on. Let me think. Or let me just look it up on Unity real quick. Direction and distance from one object to another. I'm pretty sure that it's, yeah, position and position. From the player's position to the target. So we subtract the target's, no, we subtract the current position from the target position. That gives us the direction to the target. Okay. So we want to say target direction is equal to target position minus cached transform dot local position. That is fair, I believe. Yes. And real quick, let me make sure that I'm getting that absolutely correct. Okay, I'm guessing that it gets clamped between 0 and 1 anyway, so let's go ahead and say, so if we are at target, we're going to go ahead and say generate target again. Otherwise, we're going to say cache transform dot translate along target direction. I really hope that this doesn't, I'm going to say times speed times time dot delta time. Okay. I think that will more or less do what I want. I guess we'll apply it and see what happens. So for shits and giggles, I'm actually going to change this real quick. Right, I don't have a good way of doing that. We'll add a, not private, public, if I could spell public, but I can't, public bool. Active on start is equal to false. Go ahead and go down here. I'm just going to say private void start if active on start is active is equal to true. All right. Make sure one more time. Is active. Okay. So that compile. I'm going to go ahead and drag that script onto the W, and we're just going to. And it's compiling. We're just going to see what it looks like before we activate the cutscene. We should be able to see it move a little bit. We should be able to see it jostle. Okay, there we go. Speed, max distance of 1. Yeah, this is probably fine. We'll turn on active on start. I think this is going to give us like a very crazy wobble or vibration for it. Okay. Or not. Well, that's significantly more mundane. Where the heck? Ah! Is it just continuing to move over there? Well, that doesn't make sense. Oh! Did I do position? Is that why? Yeah, no. Let's see, local origin. We do cache that, right? When we set it. Local origin is equal to cache transform, not local position. Oh, is it because I don't generate target? I don't. That would be why. Yeah, that's kind of important now, isn't it? Yep, that would have done it. It was probably, I was trying to move in a distance that is not good. It was probably using the vector 3.0 origin, which is not the best thing to move towards. Okay, is there anything else that I need to do? Local position. We're always doing local position. I don't want to ever do just regular roll position. So, target position. Let's see, is that target, local position, all that stuff's fine. Alright, let's go ahead and see what this looks like. Uh-oh. Seriously? Well, I've done something stupid, obviously. Let's see. At least we did clamp the Z-axis part of it. But it clearly is not looking at a good... Let's see what all this is. Target position. Okay, local origin is at 0, 0, 0. That's kind of to be expected. Target direction. But you should have reached that. Are you not? So local position dot x minus target position dot x. If that's greater than the stop threshold, then we're not at the target yet. That's true. So what am I doing here? I don't know, but I do know I am going to go ahead and do this. Private void on draw gizmos. I'm going to cheat a little bit here and say gizmos dot draw sphere. And we'll say, oh, that's going to, well, that sucks. We'll say cache transform dot position plus target position with a radius of 0.5f. So that should basically have us draw a sphere where our target position is. If we've done it right, it should draw a sphere like immediately right here. But that will let us visually confirm where it thinks it should be going to. As soon as Unity compiles, of course. Don't want to rush it. It takes time to get good compilation. All right, I'm going to also turn off Maximize on Play, because I won't be able to see the gizmo otherwise. So, let's see. It could be that I have the direction inverted. And it's moving! It's just, okay. Why? Question mark. Um. No, that's not right. We're not at 0 anymore. We are clearly at you. Huh. I mean, it's not like my local position is different. Let's debug this. Yeah, right? So, interesting. Okay. No. I mean, I wouldn't think that it's a transform issue. It's not. I mean, just because it's a rect transform, that shouldn't prevent it from being accurate. But then what else? What else could I do? I have to be doing something incredibly small that's really stupid. I must be doing something really stupid. So if we are active, we say if we are at target, cache transform.local position, which is no longer what it was. I mean, surely it can't be moving so fast that it gets too far away from it. That can't be right. But I kind of wonder if it is. Let me think. No. I mean, we're using cache transform.local position, which is what we want. We want to do everything locally in case I ever decide to make these vibrations happen on the move. But why would you not work? Also, this is currently rotation dependent, and I need to change that actually. Which means that we're actually going to want to. Hold on, let me think. Great. Yep. Man, that sucks. I gotta figure out rotate. It's fine. Don't worry about it. We'll figure that out afterwards. So, random.range, that's correct. Local origin.x minus max distance, local origin.x plus max distance, a random range between those two. That will give us our new target position. Same thing for y, and if we ignore axis, we're just going to be on the local origin.z. I have to be doing something here. If not ignore axis, but we're telling it to ignore axis, which means that it should just skip this. Well, I guess out of sheer curiosity, I'm going to put in debugs to see what part of the is at target is failing. Debug.log. I'm going to say x, y, and z. Okay, let's see what that looks like. This has to be a really, really stupid thing that I'm doing. I hate it when I do this. Should be one of the easiest things in the world to do, and I just... Excuse me. Haley, I need more sleep. Too much yawning. Or I just need a drink. One of the two. Ah. All right. Okay. So let's see you shoot off into the distance. So you do, and we just keep getting to X. So X is clearly not cache transform.localposition.x minus target position.x. I mean, if that's greater than the stop hole or stop threshold. Come on. Let's do a little debugging here. So our current local position is 1.5x. Yeah, that should be fine. 1.5x. While our target x position is negative 0.46. Is my local position increasing, not decreasing? Yep. We're going in the wrong way. That would be it. So let's see. Boop. Or times negative speed. Either one would have worked, honestly. So, was that really my own issue? Ugh. Figures that I would do it the wrong way. Alright. Come on, Unity. I believe in you. A little skeptically, but I believe in you. Overall. Okay. And of course not. Still busted, eh? So that's 2 moving farther away all the time. And what is the target? Target is what? All right. We're gonna like pause this as soon as we play. And we're gonna step through this frame by frame to make sure that we aren't doing something stupid. Okay. So we are at, you know, I'm also going to go ahead and do this so I can see things a little bit easier. Let's go up here to debug. All right, so our target position is negative 9. Now if we step forward, okay, we're going negative, but we're also going negative in the Y. So out of curiosity, we're going to eventually get there. Wait. Hold on. How is this not correct? My local position, the absolute value of 6. Oh, wait. Hold on. It would be negative. That would still be less than 4. So negative 6 minus negative 0.9, which would actually be plus not 0.9 basically, should come out to 0.5, which is less than 1. So, oh, but it's a stop threshold. That's right. I'm sorry. That was, oh, is that, no, hold on. Okay, so now we're at the Y. Interesting. So, okay, fine. Let's go back up here. I'm going to go ahead and flip these. So we're going to say this. Does that work? Yes. I think that's correct. I mean, at the very least, it should flip whatever values I had. But it's really... Is that not really any different from... Or is that going to be different from just making negative values of the original direction? Yeah, I guess, well, no. I mean, I don't think that that will change anything. We'll find out. All right, let's try this again. See if I have to be angry. I'm going to be very angry if I have to be angry. That will be quite annoying, quite irksome. And they're off. Seriously? Go back here to debug. All right. So we are already past our X position. So we got into the Y for a little bit. But our direction for Y is always negative. What the hell? Why? Okay, well, let's go ahead and stop playing. Let's see. If one point space is subtracted from the other, then the result is a vector that points from one vector to the other. Except it's clearly not true. Heading divided by distance. Heading dot magnitude. Alright. Well, let's go ahead and do this. Target direction is equal to target position minus my current position. So let's go ahead and flip these back again. And then we're going to need to take their magnitude. And then we're going to divide that by the magnitude, which is fair. So we're going to say target distance is equal to target distance, target direction divided by target direction dot magnitude. Okay. Then, am I really going to have to? Fair enough. So if this doesn't fix it, although I doubt this will fix it, I feel like this is just a speed change for the most part. Then we're gonna cheat and just invert the freaking y value to see what happens. Because the problem seems to be that the point in space that I'm trying to get to is always moving toward the x is always moving towards it, but the y is moving away from it, which obviously causes problems. It redirected. It did. It redirected. Yep. For one, it redirected. And we are currently moving in the positive x direction. And we are moving in the negative y direction. Because of course we are. So, again, it got flipped. What the heck? Why? So, what's really weird about this is the fact that it seems like the direction is almost what I would expect it to be. Like, not really a huge difference there, but it's just not finding it. So I'm gonna cheat. I'm gonna move this up and over. So I'm trying to get to point. So we want to get to 0.4 in the x-axis. Probably looking at something like that. Okay, we still not at z? Seriously? Look at that. We are at 0.94. So actually I want to go over to 0.6. Oh, and also I'm going the complete wrong direction, yeah. I'm sorry, what? How is that not? Oh, because the Y. I'm messing up my target direction and positions. So this needs to go up a little bit, like 0.5. So now it's changed position again, and the target position is now negative 0.7, negative 0.8. Are we going in that direction? Yes. But our Y value is going greater than our freaking... What? So our Y seems to be accelerating faster than our X direction? That is so weird. Okay. Yep. That is rather strange. Yep. Okay. So I'm going to go ahead and pause, and we're going to step through this one point at a time just to see if it's even going to the right spot. Okay, so we want to get to 0.6 by 0.8. And our direction is 0.6 by 0.7 ish, which seems wrong. I would think that our direction would actually be the same, especially because we're starting from 0. Our position is 0 right now. So that does not inspire confidence, but we will try this. So let's see. We are going negative in the X right now. Like, that doesn't make sense. Like, look at this. The local position.x is decreasing, but our direction is freaking positive. So, wait. I think I might know what it is. It's this. Ah! Great. Well, know what that means. It means that we have to make rotation independent targeting. So what we were doing right now is not rotation independent. It just assumes global X, Y, and Z. That explains why X or Y was messed up when it should be going a specific way. It's because it was rotated 180 degrees, so it's basically going the opposite direction, left or right, that it needed to go. Okay, that means we want to change this a little bit. So we have to rotate the target direction by our rotation, which I think means we want to multiply the two of them. I will go ahead and check that. Let's see, perpendicular vector. This is going to be fun because we basically have to rotate a vector. Rotate. We'll say rotate direction vector. I think we can do quaternion stuff to do this real quick. Yep, pretty much that. Okay. Yep. Okay. So let's try that. So we actually want to take our direction once it's done and say target direction is equal to cached. Hold on. Quaternion dot angle axis. Creates a rotation which rotates angle degrees around axis. That's not right, but that's what he was saying, right? Angle axis. Yes. Okay. No, this is not right. This is. No, that's right. That's right. So we want to do the. Well, no, that won't work. So we do quaternion dot Euler, I think. Not vector 3 dot up. That seems correct. So we would actually do Wait, that makes no sense. We'd be multiplying a freaking quaternion by a vector. Alright, well, we'll try it. And this is going to be cached transform dot local rotation. I'm sorry, local Euler angles. Times target direction. Will this really work? That seems like it wouldn't. We're multiplying quaternions by vectors. Or vectors by quaternions, I guess. Since we're trying to get a vector. Huh. Well, this could be interesting. We'll find out. Alright. Let's go ahead and give this a shot. Did it work? Oh! It did! Hooray! Oh, there we go. So let's go ahead and shorten that distance a lot. God, that took way longer than it should have. We'll have a max distance of 0.1. We'll have a stop threshold of 0.01. Speed of 1 should still be fine. That should actually make it jitter a little bit faster. Let's take a look at that. Should be good. I can actually probably adjust these things live, since they cache all of their initial values. Well, they don't cache their initial speed values. Let me guess. The float comparison was too small. So it, frickin' I hit close tab by accident. Debug. Alright, Great. So we're going to go ahead and pause, then play, and then we're going to take a look at this to make sure that we're in the right. I believe in you. Alright, so we're going negative x, negative y. And target direction. So I guess I should probably reopen the freaking inspector. Debug. So negative 0.5 and negative 0.8. Okay, so here it should rebound. And it does. But here I think we are moving in the wrong direction. Right? Let's see. 0.7, negative 0.5. No, it seems to be... Really? As soon as I stop pausing it and pause buffering it, it breaks? What the heck? Okay. Yeah, so our X position got completely borked, presumably because our Y positioning is just out of range. Freaking really. Okay, so I'm going to play it again. We're going to take a look at it. What, is the freaking float error threshold too small? That makes no sense at that low of a decimal place. Oh, you have got to be kidding me! Alright. We'll make it 0.5. So it's half of a freaking centimeter. Actually, that's not even a centimeter. That's like a decameter. So that'd be, what, 5 centimeters? Oh my goodness! What the frig? And just out of curiosity, max distance of 1 and a stop threshold of 0.1. If this works, then it means that for some reason our math calculations are too imprecise, and it just won't work at small distances. And that's not even a tiny distance, though, so it's maddening. Did we just get one good playthrough? Nope. You've got to be kidding me. So it works here. Let's do a max distance of 0.5. Okay. We'll do a max distance of 0.2. Honestly, that's not particularly terrible. Let's go ahead and come down here. I'm going to comment you out for now. I don't know if I want to delete you yet. So we'll do 0.2, but I guess my stop threshold is can't get any smaller than freaking 0.1 meters, because clearly centimeters are too much to ask for precision. Okay, so let's try this again real quick. So we should basically see it kind of just jostle around in spots. Oh my goodness. No. No. Hold on. Is this because there's a hiccup when it initially loads? So I'm gonna keep that at 1 for now. Then we'll shrink it back down to 2, or 0.2. Okay, so there's our movement. So there's that. Okay, now if I try to shrink this to we're actually going to go ahead and pause this. I'm going to shrink this to 0.05, and then we're going to resume. Okay, we're going to move this back to 0.1, then resume. Okay. So it very well could be that my stop threshold just doesn't work if there's a hiccup initially. That's really frustrating. But so we know that this value works. So I'm going to go ahead and test this. So we're going to set this at 0.05, 0.1. I think we did that, right? Turn this off, debug. Close you. Okay. So we're going to activate letter vibration in our cutscene, and I'm just going to see if the W is fine. Although that does mean we're going to have to add some scripting. Folder, I'm going to say activate letter vibration. I don't see why these don't have spaces. All right, create playables, and these are all going to be messed up too. So this is going to be activate letter vibration behavior. Let that compile, and then we'll create a activate letter vibration clip. And we don't need a custom track for this, because all they're going to be doing is referencing the letter vibration stuff. Let's go ahead, say create playables set. So activate letter vibration clip. Not clip. Okay, let's open these up. Reload. Okay, let's see. So for this, we're going to need to say public can't really do anything yet because we need to namespace this first. BL.textQuest. Alright, so we're going to say public letter vibration target. We don't care about anything else. That's all we want. Don't need to do graph, start, or stop. We just need on behavior play. We don't care about anything else. Get rid of all of you. Just going to go ahead and save. File, advanced save, Windows. All gravy. I'm going to say if application dot is plain target dot is active is equal to true. Oh, I lied. I do want to have override on behavior pause because I need to say set is active to false at the end here. Okay, and that is probably the best. I am going to real quick go down here to letter vibration. We're going to get rid of on draw gizmos. And I am going to say else cache transform dot local position is equal to local origin. So we're going to reset our positioning whenever we deactivate this. Excuse me. All right, now we need our clip to be coded once Unity compiles. And then we should have the initial appearance of the wizard finished up. Well, not the appearance, but the landing of it. Let's see. You up here. Space sleepy owl dot text quest. All right. Same thing we always do. Script playable. Then what is it? Activate letter vibration behavior. Playable is equal to script playable. Activate letter vibration behavior dot create based on the graph. Then we're going to say activate vibration behavior. Behavior is equal to playable.get behavior. Okay, we're going to return playable here, and we're going to go ahead and say behavior dot target is equal to null for now, because we need to come up here and say public exposed reference activate. Letter vibration target is equal to target dot resolve graph dot get resolver. All right, and that's all we cared about. Okay, so let's go ahead, let that compile, and then we can add that to our timeline. So I'm legitimately curious if the reason that it was breaking before was because of an initial stutter caused by the scene activating itself. So I wonder if activating this while the scene's already loaded will prevent that from happening. Because as you saw, it only happened if we had very small distances while the start of the scene was happening. So that's really annoying because I probably should. Hell no. I mean, I could move it over to instead of update, use fixed update, but that would be weird. It would be consistent and it would prevent things like that from happening. But all right, let's go to timeline. Wizard appears. Impacts. Let's go ahead and have a track subgroup that we'll just call effects, I guess. We'll add a playable track. We're going to say add a clip. Activate letter vibration clip. We'll take this. Let's go ahead and once these are fully done, we'll have it vibrate for, I guess, 5 seconds. We'll shorten that to 3 seconds. And then it should stop. Ah, crud. That actually... we'll shorten that even more to 2 seconds. So it'll stop vibrating as the beard hits it. Okay, so let's try this scene out. Curious to see if we get anything useful from this. Okay. All right. Landing and vibration. What happened there? It just... What? Okay, let's increase that to 0.2, I guess. That was weird. Like, it was definitely animating, but it basically just stopped. Oh, no. Oh, dear. I think I might know what it is. Freaking crap. Here's the problem. And it is one that I didn't think about. Yep. Oh, that sucks so much. Right. So, the reason we're not seeing the W vibrate is because its position is keyframed. So the timeline is forcing its position back to 000, basically. Oh, crap. The way to get around that would be to move a parent object instead of it. Ugh, that sucks. Yeah, that's about right. That is about right. Well, let's see if I can break that real quick. If not, we might just call it a night. Yeah, we're just going to probably call it a night. Because it looks like it's just going to force that position for the rest of the clip. Freaking great. So I have to redo that all. Well, let this be a lesson, I suppose. When you're working with timeline, never, and I mean never, animate the object itself. Always animate a parent. That way you can do specific things with the object in relation to its parent. And if you do animate it directly, then you get what happened here. I can't do a procedural jostling effect because keyframing won't allow that. Okay, well, that's as good a spot as any to end tonight. Because otherwise we'd be doing the exact same thing we just did. This sucks. Alright. Announcements, real quick. We are not going to be streaming this weekend because I have friends and family things to do. So I am not going to be able to stream. I will still try to get this more or less done and post maybe some screenshots about this. So hopefully we'll get some updates about that over the weekend, but I'm not going to be streaming on Saturday because of friends and family. So, all right. Let's see, any other announcements? No, that should be good. So, as always, I want to thank you all very much for watching, and I will see you all next time.